Welcome to the June 2024. This is paper 2 of the 1MA1 series, the Edexcel GCSE. This is the second paper, which calculator paper. So C to B is going to be Pythagoras in reverse, square root of 19 squared minus 10 squared, which is 16.2. For 2a, we can split 90 up into 9 and 10. 9 splits up into 3 and 3, 10 into 2 and 5. And so we get 2 times 3 squared times 5 as the product of its prime factors. For b, lowest common multiple of those two. So they're taking the largest power of each square number in both. That's the 2 squared and the 3 squared is 36. You can just work those out by hand if you really want to. The numbers are small there. Alright, substituting n to be 6, 72 divided by 6 is 12 hours. 72 divided by 9 is 8 hours. The difference between 8 and 9 is 4 hours. So 4 hours difference. Reverse the calculation. 24 divided by 0.16 means that there are 150 discs in total. Subtract the 24 yellow ones from that to give us 126 other discs, and then split those 126 in the ratio of 5 to 4. Divide 126 by 9 to get 14. 5 lots of that is 70. So there are 70 red discs in the bag. Question 5, substitute -1, 1, 3 into the equation. You get 2, 0, and 6. Then plot your points and draw a better graph than I have. So there's 0, 0, 1, 0, 2, 2, and 3, 6. And then have a go. Try and make it smooth. Get it through all the points. It's a curve, so there shouldn't be any straight bits. Yeah, not great. Anyway, for the second part, I've drawn y equals -4, and I've read off the x coordinates where that happens, -1.5 or 2.5. These are the solutions to the equation. For 6, we want Tina to give 3/7 of her sweets. So 3/7 of her 14 parts are 6 parts. So 6 gets added to Andy's 1 and taken off Tina's 14. So we now have a ratio of 7 to 6 to 8. 12.5% is the same as 1 part of the 8 she has left. So she gives 1 of her parts from her 8 to Luke's 6. So Luke's gets 7 parts, and Tina is reduced to 7 parts, so they're sharing it in 7 parts to 7 parts to 7 parts. So yes, Tina is indeed correct. Well done, Tina. Angles in a quadrilateral will sum to 360, so that allows us to construct an equation. Add together the 4 angles. And that gives us a way of solving it and finding the value of x. So collect like terms, collect the x's, collect the non-x's, subtract 35 from both sides, and divide by 13. We work out x to be 25. Substituting x to be 25 into the four angles, you actually need only to pick 2 of them. If you pick the 2 on the left, you'd get 115 and 65. If you pick the 2 on the right, then you get 108 and 72. Now the good thing about that is if we sum the pairs of angles together, we get 180 in both cases. Getting 180 in just one of those cases is sufficient for us to conclude that BC and AD are parallel because of, and then whatever you want to call it, they'll accept anything from co-interior, allied, even supplementary angles. The names for the angles sum to 180 on a pair of parallel lines, and that's because of any of either of those pairs there. So you could do ABC and BAD, or you could have done BCD and CDA. Once you've spotted that you've got that set up, you can conclude that BC and AD are going to be parallel lines, and because a trapezium is defined by being a quadrilateral, exactly one pair of parallel lines, that's enough for us to conclude that ABCD is indeed a trapezium. For the triangular playground, 40 divided by 5 is 8. So that side length there is 8. So 28 will be equal to a half times base times height, half times PQ times QR, which is 8. And therefore we can deduce that PQ is 7. Then 7 times by the 5 means that it's 35 meters in real life. For the rounding one, lower bound of that's going to be 7.25. And I'm afraid, Layla, that the answer is no, you're not correct. I've picked a number there that is bigger than the number that she has given, and yet would still round down to 7.3. That would do it. Any argument that shows that there are numbers larger than hers which would still round down will do the job there. Question number 10. So we've got two triangles using a bit of SOHCAHTOA. There is a mistake here. Anyway, sine A is equal to 7 minus 2x over 8, and that should say tan B is equal to 1 plus x over 4. Remember, it doesn't count before you write in. It doesn't count if I spot it during the commentary. So don't write in, I know that's a tan B there, opposite over adjacent. Anyway, equating the two, I probably should have multiplied both sides by 8 here, but instead I went with multiplying, cross-multiplying, bringing the 8 up to the top right, bringing the 4 up to the top left, and expanding it out, going on to solve it to get x equals 1.25. For the cumulative frequency, 7, 28, 43, 54, 60, just adding on each one each time. And then we're going to plot those points on the cumulative frequency graph. It's one of the few occasions you can do a dot to dot, so you can, if you want to, you can do it smooth by hand if you want to, but my by hand graph's always terrible, so I've done a dot to dot on this one, like so. Let's draw the IQRs at 45 and 15, because a quarter of 60 is 15, 3/4 of 60 is 45, and you can read off the interquartile range weights of 6.4 and 2.8. Subtract the 2.8 from the 6.4 gives you 3.6. Any answer between 3.4 and 4 is acceptable here. For D, drawing the line up at 7.4 and going across, reads 51, so 51 to 60, we'll subtract 51 from 60, giving us 9. Within that range, anything between 7 and 10 is acceptable according to the mark scheme. Question 12, f is inversely proportional to d squared. So I'm going to set that up. F is inversely proportional to d squared. Turn the is proportional symbol into an equals k. So f equals k over d squared. We can substitute f for 3.5 and d for 8. 3.5 equals k over 8 squared. Multiply both sides by 8 squared to find k. And so k is 224. That allows us to write the equation connecting f and d as f equals 224 over d squared. When f is 10, substitute 10 in. So 10 equals 224 over d squared, multiply both sides by d squared, divide both sides by 10, and then you can square root to find d. Rounding it to 3 sig figs, d comes out as 4.73. Okay, for the inequalities, let's draw the line. So there's x equals 2, we've got y equals negative 3, we've got y equals 2x plus 1, and 3x plus 2y equals 6. Then you can test a point, whatever way works for you, testing a point on all of them. The point 0, 0 will work in all of them, so you know that's in the region we want to, and then do your best job at shading it in, and then labelling it R. There we go. Should look something like that. Okay, we want the gradient of the velocity to give us the acceleration. So draw a tangent at the point where t equals 5, and then you got to pick 2 points to construct a triangle off if you want to do it that way. Or pick 2 points and do the y2 minus y1 over x2 minus x1. I've got those 2 points there, which comes out as negative 2.27. It's unlikely that you'll get the same answer as anyone else, but anything between negative 2.0 and negative 2.8 will be correct. Then for the area under the graph, which gives us an estimate for the distance, so we're essentially adding together 3 trapeziums. The first one on the left between 0 and 2, well, it's got a height of 25 and a height of 16. Obviously the trapezium's on its side, so in the formula the h is going to be 2 there. So a half of 25 plus 16. For the second one it's 16 and 9, and for the third one it's 9 and 4. There are clever ways of grouping those together to make the calculation shorter. Well done if you've done that. But you should get 79 either way. To rationalise the denominator, multiply by its conjugate pair, which is going to be root a minus 1 over root a minus 1. That fraction is of course equivalent to 1, so we're not changing the value of this fraction, we're just changing the way it looks. 1 times root a minus 1 is root a minus 1, and then root a plus 1 times root a minus 1, well, root a times root a is a, and plus 1 times minus 1 is minus 1, so it's root a minus 1 over a minus 1. 16, if you can visualize these, it's really easy. So this is a quadratic equation. The critical values are negative 5 and 3/4. It's a smiley face one, and when is that below the x-axis? It's that region there where the sort of the goatee beard is. And so the values of x are going to be the ones in between the two critical values. So negative x is less than 3/4. There are other ways of doing those sorts of questions, but that one's nice and simple. Question 17, we've got our similar cylindrical solids, L, M and P. It gives us the scale factor of volumes between L and M to be 64 to 125. Mass, of course, will be proportional to volume. So 64 to 125. Cube rooting those to find scale factor of lengths will give us 4 to 5. That's between L and M. Then it gives us information about the surface areas of M and P, so that's telling us about the scale factor of areas as 144 to 16. We can square root those to find the scale factor of lengths, which is going to be 12 to 4, or if you prefer simplifying 12 to 4, you'll get 3 to 1. Then you've got 4 to 5 and 3 to 1, so 15, if we aim for 15 in the middle, multiply the 4 to 5 by 3 and the 3 to 1 by 5, you're going to get 12 to 15 and 15 to 5, so as a single ratio, 12 to 15 to 5. Okay, question 18. for there to be more yellow counters than red counters, there's two ways of doing that. You can either pick 3 reds or you can pick 2 reds and a green. For the 3 reds, well, 4/8 chance of picking the first, 3/7 the second, 2/6 the third. Multiply those together, we get 1/14. Then for 2 reds and a green, there are actually 3 different ways we could do that. We could get red, red, green, red, or green, red, red. The probability of each one is exactly the same. So I'm just going to multiply by 3 at the front to cover that. We've got 4/8, 3/7, and 1/6. Technically, for each of the different versions of those fractions will be different, but because we're multiplying them all together, it doesn't matter. So 3/28 is the correct probability. Adding the 2 fractions together, because we don't mind which one, gives us 5/28 as the overall probability. Question 19, the vectors question. We know we have the ratio of 4 to 5 on the right hand side there. B takes us from O to B and A takes us from O to A. First thing I'm going to do is I'm going to construct a vector B to C. So B to C is going to be the same as B to O plus O to A plus A to C, which is minus little b plus little a plus k lots of little b. Those are the 3 vectors they gave us in the question. I'm just going to factorise that to give me 1 lots of a and k minus 1 lots of b. You don't have to do that. Then m to n, which is the vector we're searching for. My pathway, I'm going to go from m to o and then o to b and then b to n. M to O is straightforward, it's negative 1/2 little a. O to B is straightforward as well, it's B. And then B to N is going to be 4/9 of B to C. Because they're split in the ratio of 4 to 5, B to N is going to be 4/9 of B to C. So simplifying all of that, we've got minus 1/2 a plus B and then plus 4/9. Now we've already constructed B to C. So I'm going to replace B to C with A plus K minus 1 lots of B. Now once it in its simplest form, so I'm going to expand all of that out. There are a few variants on its simplest form that would be perfectly acceptable. Anyway, I've got minus 1/2 a plus b plus 4/9 a plus 4/9 kb minus 4/9 b. We can group together the little a's to get minus an 18th a. That's the one you need. And then this, I've factorised all of the things out of the little b. You didn't have to do that. You could have 5/9 b plus 4/9 k lots of b. Either of those would be fine, as long as you collected the a's together, because they will simplify. Is mn parallel to O to B? No, because we can see mn has got minus an 18th of little a in it. O to B is just a scalar multiple of little b, so no, they are definitely not parallel. Alright, question 20. So to find the turning point and complete the square, you can, if you know how to, you can differentiate, equate to 0 and solve, and then substitute your x value back in. Anyway, completing the square, factorising out to 2 from the first bit, then completing the square with x squared minus 6x, so it would be 2 lots of x minus 3 squared minus 9, and then plus 7 at the end, expanding out the 2 lots of x minus 3 squared minus 18 plus 7, join it minus 18 and 7 together, 2 lots of x minus 3 squared minus 11, it's got a minimum point at 3, negative 11, you can read it off at that point. Alright, we're reflecting this in the y-axis and then shifting it 2 places up. So take each vertex, reflect it in the y-axis, shift it 2 places up, and da-da, there's your new shape. Not the best there, I think I missed it slightly, but there we go. Okay, to find that A to P is equal to B to P, I'm going to split this up into two triangles and we're going to compare the length. So O to A and O to B, they are both radii, so they will be equal. The length O to P is going to be equal to O to P, obviously, it's the same line. Angle PAO is going to be equal to angle PBO. They're both going to be 90 degrees because of the circle theorem that says that the angle between a tangent and a radius is always 90 degrees. So we have a right angle here and two lengths, and that is sufficient for us to meet the condition for congruency. Therefore, I can state that PAO and PBO are congruent. Those are the triangles, PAO and PBO, rather than the angles. You know the triangle, that's the RHS condition for congruency. Once we have congruent triangles, we can conclude that A to P must be equal to B to P, which is what the question wanted. Well done if you got that. Bye.